What's happening, dogs? Mr. Allen here with some solving of exponential equations here, but these are a little bit different, okay? We don't have like bases in these two problems. We can't even rewrite them with like bases in these two problems here. I mean, the algebra in this one is going to get exponentially fun, if you will. All right, so normally, if I had 4 to some power and maybe I had like 8 to some power, I'd write it as 2 to some power. But we can't do that here with 4 and 6. So what we're going to do is we're going to take the log on both sides. You could use natural log, log base 10, log base whatever you want. I'm going to go with natural log here just because it's 2 letters rather than 3 letters. That's cool, right? All right, cool. So there we go. I took the log on both sides. Now what I can do is I can take my exponents, okay, and I can write them in front as a coefficient. So now what I'll have is 2x minus 3 times natural log of 4 equals, and we'll have 5x plus 1 times the natural log of 6, all right? I can take an exponent and write it as a coefficient. That's a log property. Okay. Now, it looks really, really terrible right now, right? It looks awful. But natural log of 4 is just some number. If I typed it in my calculator, which we're going to need here in a little bit, but if I typed in natural log, hold on, it's validating the OS. 1 sec. There we go. Okay. Natural log of 4, I get 1.3862, blah, 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 right? I just get some kind of a number. So I just have a number times a binomial, right? We've dealt with that before. If this was a 3, I could just distribute it in. And we're going to do that, but I am going to leave everything in terms of the natural log for now. We're going to type it all in at the end of this whole thing, okay? So I'm going to distribute in the natural log to both these parts as well as on this side, okay? So we're going to have 2. I'm going to write it, I think, in the way that makes most sense to me, all right? So we're going to have 2 times natural log of 4 times x. And I know we don't need the multiplication sign there, but I feel like it helps separate things a little bit. Minus 3 times the natural log of 4 equals, and over here we have 5 times the natural log of 6 times x, and then plus 1 times the natural log of 6, so we're just going to have plus natural log of 6. Okay, so there we go. We distributed in, and now again, we're just dealing with a bunch of numbers and a couple x's, right? So if I was dealing with an expression of a bunch of numbers and some x's, I'd try to get the x's on one side, the numbers on the other, right? And that's what we're going to do now. So I've got this 2 times the natural log of 4 times x. I'm going to leave that here. So we're going to have 2 natural log of 4 times x. So I'll put the multiplication back. All right, and then I'm going to subtract this guy over. So we're going to have minus 5 times the natural log of 6 times x. Then I'm going to add this to both sides, right? But we're going to have our natural log of 6 still here, natural log 6. Then I'm going to add the 3 natural log of 4. Okay, there we go. Still looks terrible, yes? Still looks absolutely terrible. And just in case you missed any of those steps of what I just did here, for proper algebra, really I should have minus 5 natural log of 6x on both sides. And we added the 3 natural log of 4, add 3 natural log 4. Okay, cool. So now what we have here is a number times x minus some number, 5 times natural log of 6 is a number, times x, all right? And again, we could plug this in, get some decimals, and actually put it all together, but I'm going to wait till the end there. You know, YORO, you only round once, so I'm just going to wait till the very end for all these calculations. Instead, I'm going to take out an x here. I'm going to factor out an x because that's a common factor out of these two terms here, right? So now we have x pulled out, and I'm left with 2 times the natural log of 4, 2 natural log of 4, minus 5 natural log of 6. This side, I'm just going to leave it as is, okay? Natural log of 6 plus 3 natural log 4, all right? This is just a number, right? Times x. Can't I divide by said number to get x by itself? Heck yes, I can. All right, we got 5 natural log 6. Divide that on both sides. 2 natural log 4 minus 5 natural log 6. Whew, those are gone. I've got x now, and I'm going to type this all into my calculator at once. Okay, so I'm going to hit alpha x. For a fraction, you can hit alpha y equals and choose n over d if yours does not have the alpha x thing that I just did there. All right, and then my numerator is natural log of 6, close your parentheses, don't forget to do that, plus 3 natural log of 4. Then I'll arrow down to my denominator. We'd have 2 natural log of 4 close the parentheses, minus 5, natural log of 6, close them, hit enter. You can also just do division with parentheses around the numerator and around the denominator, then a slash division, all right? So for x here, I'm going to get, now I'm going to round, very end, I'm rounding one time, right? One time. We get negative, I'll do 3 decimal places. It's negative, let's see here, 0.9619 and change. So we're going to get negative 0.962 for my approximate x value there once we've done it all. Now, let's check it out in the original equation, shall we? Okay, so I'm going to type in our rounded answer. We should get pretty dang close to equal on each side. So I got 4 raised to the 2 parentheses, negative 0.962, close them, minus 3, and I get 0.001085, blah, blah, blah. And now I'll try with the 6 raised to the 5 parentheses, negative 0.962 plus 1. And I get pretty dang close to the exact. I mean, we're a difference at the 6th decimal place, right? If I actually use the really long decimal that we had in the calculator there, it'd be pretty much the exact same thing. But there we go. I can check it, make sure we did everything right, because there's a lot of room for mistake there. Okay. That was a lot, man. What I would suggest now, all right, is hit the old pause button on this video here and try this one on your own. Try not looking at these steps right here. And then when you're ready, I'm going to work through it right now. I'm going to explain it again just in case you need that explanation. But if you need to, just skip ahead to the solution. Maybe I'll put a little time marker in here so you can just click ahead and go right to the solution if you want to check it. And then if needed, you can pop back, watch the explanation. You know what I'm saying? All right, I'm just trying to help you out. All right, you've had enough time to pause this thing. I'm getting after it. Let's get going. All right, I'm hungry for that math. Okay, so again, we're going to take the natural log or log, doesn't matter, on both sides. I choose natural log. It's less writing. Then I'm going to move my exponent out as a coefficient. That is a property of logarithms. So we've got parentheses 4x plus 1 natural log of 3 equals 5x minus 4 natural log of 2. Then I'm going to distribute that natural log in. So we're going to have 4 natural log of 3 times x plus 1 times natural log of 3, so natural log of 3. So you can write it like this. See, I didn't put the multiplication here like I did on this one to like break it apart. Now I think we can see what the heck's going on. If you want, you can even like throw parentheses around that 3 there for the natural log so you can see what's in the argument of the log. Maybe I'll go ahead and do that. We'll do a slightly different notation this time. There we go. Okay. Now we can clearly see the x is not in the argument of the log. It is outside. Okay. All right. Next part, we got 5 natural log of 2 times x minus 4 natural log of 2. All righty. Lovely. Time to get our x's over. So I'm going to subtract 5 natural log of 2x on both sides. And we're going to go ahead and add subtract natural log of 3. Boom. Okay, so those cancel. These cancel. Now let's rewrite it. So we've got 4 natural log of 3 x minus 5 natural log of 2x equals, and then we have negative 4 natural log of 2 minus natural log of 3. Okay, beautiful. Now I can factor out my x here, leaving behind just the stuff with the logs there, which is just a number that we can divide by eventually. So I'm going to take out the x, and then we got 4 natural log of 3 minus 5 natural log of 2 equals, and over here it doesn't really change, right? So negative 4 natural log of 2 minus natural log of 3. All right, boom, boom. Okay. Now I can divide by this whole beast right there, get x all by itself, type it on the calculator, one swooping motion, if you will. All right, we got 4 natural log of 3 minus 5 natural log of 2. And then once again over here as well. Man, this is intense algebra here. That's really all there is to this one. I know that sounds like, okay, yeah, sure, it's just the math, bro. Of course, that's what it is. It's a terrible natural log. But again, you just really got to keep track of that stuff. It's just a lot of identifying. I like to think about things like, what is it really? This is just a number here. It's a terrible decimal, but it's a number no less. So you can treat it in the same way that I normally would treat a number. I would be dividing by said number. It's just an awful looking number. All right, so that's gone. So now we got x equals. Let's type it all in. Whew. All right. Alpha x or alpha y equals, or just parentheses, start your division, okay? We got negative 4, natural log of 2, close the parentheses, minus natural log of 3, close them. Oops, I accidentally hit enter. There we go. Got to go to the denominator first. 4 natural log of 3 minus 5 natural log of 2. Okay, and the same thing here, even if you did log, like I was saying before. If you just did log, which is log base 10, you get the same exact answer. Okay, we get ourselves negative 4.1683 and change. So we're going to go with negative 4.168 will be my final rounded answer. Only rounded once. Let's just check it just for fun here, right? I can do 3 raised to the 4. Actually, you know what? I'm going to do this. Check this out. Okay, I'm going to hit store as x. Okay, hit enter. Now it's stored in there as my x variable. And I can actually just type it in as I see it like this. 3 raised to the 4x plus 1. Hit enter. And I can do 2 raised to the 5x minus 4. Hit enter. And I get the exact same answer here, which is a really, really small number. We got the e negative 8. That's saying we're going to move the decimal place 8 places to the left. So you're going to point 0.0000003. So a really small number. All right. There we go, man. We got it. We solved it. Got our x values. Both of these problems, they're beasts. But hopefully now you guys can handle this type of situation when you have solving for an exponent and you can't write it with like bases, and there's both sides are exponentiated, if you will. Because if only one of them was, I could like loop and swoop this bad boy. You could do that actually here too, and that it works out pretty much the same. I just like taking the log on both sides, using my power rule. Boom, diggity, dope, done. That's it, man. That's a lot. Hope you guys enjoyed it and are still here. And if you are, like it, subscribe it. America.